Next speaker, the final one before the lunch break, Ozgun Kultekin will tell you about SIEM slam, tricking modern SIEMs with fake logs and confusing blue teams.
Hey everyone, firstly I'm very honored and pleased to be here. Thanks for your kind invitation and this amazing event. It's very nice to see the crowd here. So we will dive into SIEM slam, tricking modern SIEMs with fake logs and how to confuse blue teams. It's what is my favorite. So who am I and what I do? I'm Ozgun Kultekin, I'm 23 years old, a little bit younger maybe, I don't know. And I'm currently working as an offensive security engineer at Trendyol Group. My main focus is on penetration testing and breach and attack simulation. In terms of pen testing, actually, I'm also organizing some outsourced penetration testing for each business of Trendyol and conducting some internal penetration tests on assets ranging from web application, Active Directory to SCADA. And we are also do consulting jobs for internal customers and coordination with third-party vendors and internal customers. In terms of breach and attack simulation, we are planning and I'm planning and executing some red team operations and purple teaming exercises with blue team. We are working closely with blue team. And we also doing some evasion and bypass techniques on security technologies such as web application firewall, EDR, NDR, DLP, and email security. And not the topic of this conversation, but we have a project that to include both attack simulation and manual purple teaming activities into one metro attack framework heat map in order to track policy detection and technique coverage. This may be an open source tool in future. So how it all started, like how we decided on researching about that. This project actually is a result of one of our breach and attack simulation team process. And because we take security devices, this can be your typical EDR, WAF, IPS, NDR, SIEM, email gateway security. And we are just looking for configs in order to bypass some controls, looking for faults in the app that later turn into CVEs maybe. And we were taking a closer look at SIEMs because SIEMs everywhere, and we just looked for how they are built, how they are carrying data. And we also some data from our red team operations showing us that winning time will be really beneficial. Like if you're conducting red team operations, you will probably notice that we need same time. So we decided to look further into this, and if we have root privileges, we can just kill the, Splunk, SIEM, EDR, right? Because in terms of Linux, this thing's kind of easy. We can just kill it. But why kill it? Why we are stopping there? Why not manipulate the SIEM logs besides killing it? So this research came into light. So what are contents? We will start with talking about some rules of our presentation, then introduction, then what's our problem and what we did to solve it. After that, explore and exploit. We got some 3-minute demonstration video. After that, endless ways to cause distraction, fighting back for blue teams, and then roadmap. Okay, let's start with some rules. Okay, in this room we are like 10, 100 people. So how many of us are using SIEM tools in a week? Yeah, we are using it actively, right? Okay, we have tons of logs and we are using it because we trust it. Okay, so now rule number 1, never trust logs and never trust your SIEM. I'm sorry, but yeah. And you said that a lot of us using SIEMs, right? How many of us using Splunk? Oh yeah? Yeah, you shouldn't say about that because if some random kid presenting at a conference asks about the SIEM product you use, you shouldn't ask for that because it's not safe anymore. You will notice that. So let's start with introduction. SIEM. What is SIEM? SIEM is like basically security information and event management, right? And as you know, it's kind of very popular these days because Splunk has been sold about 28 billion, and a company accurate that is between us, so maybe let's not talk about that. And what it does is actually it's an essential tool for many companies, for blue teams, because it's center of the security operations for a long time. It collects and analyzes data because it enables blue team to detect some potential attacks and enables them to respond it quickly by collecting and analyzing logs from various resources. This resource can be Linux, Windows, or SCADA, and it generates alerts according to this written rules, right? So it also helps with compliance and regulatory requirements, like PCI DSS, GDPR, because they need you to have some audit capabilities, and SIEMs is here for that. It also allows you to have historical analysis and forensics. Let's say if you had a security incident, I hope you're not, but if you had that, you can just look back, historical analysis and forensics about that. It depends on your configuration, but generally you have data from the month earlier, right? So I have a best friend these days. It's called ChatGPT. Maybe you heard of it. He's a very popular friend. And I asked him about what's the most popular SIEM solution in general, because I don't want to directly targeting Splunk. I don't want to get in trouble. So I'm accusing ChatGPT right now. And he said that Splunk is very popular, and there's also some solutions, QRadar, Logarithm, McAfee, but Splunk is far popular than them. But it's a dynamic market. So let's start with talking about Splunk a little bit. I'm just introduce some structure of Splunk, then we will delve into the attack. So data sources, as we said earlier, SIEM tools can collect logs and data from various resources. You can see that there is on-premise, cloud, and applications. And there is forwarders. What is a forwarder? Forwarder is just an agent you deploy on this data sources, and it just collecting the logs and sends them to the indexer. It has two types, not so important, but universal forwarder is just forwards the raw data without any prior treatment, just sends the whole raw data, because it requires less resources on the host, but result in huge quantities of data to send indexer. On the other side, heavy forwarder, it performs some parsing and indexing at the source, at the data source, and sends only the parsed events, like the event itself, to the indexer. So the next one is indexer. Indexer just transforms the upcoming data into events. So it stores into disk and enables the searchability mechanisms of Splunk. Searchat, as we know, is just a UI to use to interact with Splunk. And we can just search. Searchats manages the indexers, and forwarders just consume the data. Indexers index and search the data, and searchats coordinate search across the indexers. And there are lots of different structures of the searchats. There can be more than one searchat or just captain searchat, but it's not that important in our case. And there's also Splunk Management Console. It's just a web-based interface for administration purposes. And the last is Splunk Web App. It's just a superstar of the Splunk, because that's the screen we all just looking at it. And it's the main attraction, but it's just actually the fancy interface, because the background is this whole complicated thing. And if you miss Splunk, then that's the view. So as its simplest, you can think SIEM structure is just like this. There are just some data sources and forwarder agents on them, one indexer, and indexer to the searchat or Splunk Web UI. Okay, so what was our problem and how we solved it? Let's follow some hacker's trail, and I think the red and dark team didn't work. So let's start with first. Initial access, like attacker has, let's say, successfully compromised a target's computer within a large company. Let's hypothetically think that an attacker compromised a machine and have some root privileges in very large company. Right now we have a compromised machine, we have root privileges, or you can say system privileges in case of Windows. Well, what can we do is we can exfiltrate some data, right? Because we already compromised, maybe we started with phishing, sending malware. It doesn't matter. We are in right now, and we are just talking about what can we do in that stage. We can exfiltrate data, right? Stealing some sensitive data, or we can just cause disruption, disrupt some business operations, or we can just launch a ransomware attack. But in general, we need to discover more and more reconnaissance, more targets to find. But at the end, whatever you want to do, it's just leaving traces, right? So we have really limited time after getting root privileges because blue team is on their heels. They are chasing after you. You need some time. You need some maybe chaos. So in this hypothetical scenario, what can you do? In an attacker, what should an attacker do to not get caught before exfiltrating some sensitive data? And the answer is creating fake logs. So let's say you have the ability to create fake logs. So how can you use it? You can create some mimic. You can create some another attack, right? You can just pretend that someone just hacked into the payment server and got full control. It would cause a lot of confusion and panic, right? You are compromising another machine, but you are just showing that the payment server got hacked. So blue team need to deal with this, and you are just playing around there. Or you can some completely made up events, like someone running a secret network scan, injecting dangerous payloads, XSS payloads everywhere. You can just mimic that. Or if these are not enough, you can just spam logs, spam thousands of logs, and let the blue team deal with it while you exfiltrating sensitive data. So this is a hypothetical scenario. Let's say we compromise the host, Windows host, in the target company, and we have some secure network. We just say that we discovered that secure network with some reconnaissance inside, and in this time we can just show that a payment server 01 is hacked. So blue team probably just want to deal with this because it's the most important assets of them. So our research focus is actually pretty evil because in our original research, we have discovered that one particular effective strategy to create and insert fake logs into the SIEM tool, which can in the end mislead and distract the blue team and hide the real attack. And in this presentation, we will explore how attackers can use these fake logs to deceive security operations and how security teams can defend against these defacements. We will focus specifically on Splunk, a modern SIEM tool, and demonstrate how to create and inject fake logs to mislead the blue team. So as you can see, this study can also be used as a part of the red teaming operations. And all these images are created with full of AI, like the prompt of this hacker injecting fake logs, dark teamed, hiding from blue teams. I typed that prompt and this came out. Not bad. And chapter 2, explore and exploit an introduction to log slapper tool. We are just releasing probably this month. Of course, open source. Don't look mad at me. So in our research, as I talked about earlier, we focused on creating and injecting fake logs on Splunk. So we actually just did a man-in-the-middle attack between the forwarder and indexer, like the data source and indexer. We were just between them. We intercepted the TCP traffic, and we noticed that there are plain text logs. It was not easy to read, but you can just parse it and make it readable. Why do we have plain text logs, right? Because it's default of Splunk. Probably on your company you are using that too. I'm sorry. So we extracted some useful headers, executed command, hostname, IP address. Let's say you are using your lovely Linux machine and just typed sudo cat etc shadow, right? So this command line send it to SIEM as a SIEM data, and we can capture it as an executed command, the cat etc shadow hostname of your Linux machine, and IP address of your Linux machine. So we successfully intercepted this TCP traffic and parsed it and modify it. Like we changed the hostname, we changed the IP address, we changed the executed command, and it just worked. So we can, in this point, we could just show that any machine in the network or this machine could be completely made up. It doesn't need to be in the network. we can show that as it's hacked. So we fix the TCP packet structure because you need to obey some rules like some predefined length checksum. So we fix them and send. So this is where we are. In the first step, you can see that outgoing SIEM logs from forwarder to the indexer. So we built a queue there, like between them, but it's not have to be between them. You can just build an NFQ structure within the Linux IP. You can use IP tables to build that queue. That's what we did. So attacker intercepts the packet from queue because all outgoing packets from forwarder just queuing there. So we are just one by one intercepting these packets and analyzing it if there's something to change, and just we modify the packet and resends to the startup beginning of the queue. And after that, modified logs just goes to the indexer. After the indexer, it goes to search it, and you can see the right top point, you can see the confused blue teams. So, okay, we talked about modifying data, right? Modifying log data, but actually we can just create a log. And it's also AI picture of birth of a fake log, and it's pretty good actually. So instead of modifying real data, brand new log also can be created because we are, while actively monitoring the real-time traffic, if you have the ability to execute OS commands simultaneously, you can capture the SIEM traffic you generate yourself, and you apply the same read and modify operations as mentioned earlier. So while you're inspecting the real-time traffic, you just execute some OS commands, and you will capture your own log and modify it. So it's a completely new log. So that's our tool. Log slapper. It takes two arguments, execution file and host file, which I will explain it later. And for demonstration purposes, now it has two separate parts, log slapper and slap now, and I will explain that too. So it's log slapper, and we will analyze this with a demo. So in a scenario, let's think that we should execute a ransomware scenario on behalf of another host in the network. Like the previous scenario, we hacked into a machine, we compromised it in a very large company, and now we need to show that a ransomware happening in another host in the network. So let's say original host name that we compromised firstly, it's called Ozgun's machine. And my host IP ends with 64. I had to blur that because I used some of my own machines. And let's say target host name will be Tirana demo. That will be the name of the machine we want to show that it had ransomware. So target host IP will be changed to 10.30.102. So we will start with creating two separate config files. First one is execution file. You can see that there are some commands and slips between them. So this is the file you want to show that the target computer just executed them. So target computer just pinged the ozgunsmaliciousite.com, then download some randomware tar.js, then sleeps 10 seconds because I am just trying to simulate a real person, so I put some sleeps in them. And then it's just decompress the randomware, goes into the change directory and execute the ransomware or randomware. And the host file is the thing we always wanted to replace, like our original IP ending with 64, now it will be 10.30.102, and our original hostname, Ozgun's machine, will be replaced by Tirana demo, because Tirana demo will be the machine I am targeting right now. So at the end, Tirana demo will look like it's executed these commands in order. And how does that work? So let's say that your execution file is like that: invoke web request, ozgun.zip, and some malware Ozgun, 3 times sleep, and then run the malware Ozgun in a Windows file. So what slap now does is it just turns that commands into some hashes, some unique hashes, and just executed them in the machine. So you will see in the execution there are just some made up commands. We are doing that because in the parallel, log slapper will inspect the real-time traffic, and it needs to find this specific hashes. So these are just indicative hashes to find and modify them. So slap now tool just run sudo 5ad blah blah hash, then sleep 3 seconds, then sudo ac64 this hash. And in parallel, log slapper look for those strings and just modifies it and injecting to SIEM. And this is another explanatory. You can see the Hacktivity machine, left bottom. This is the compromised machine in the very large network, let's say. You build a queue, log slapper inspecting the real-time traffic by looking at the queue, and in parallel, slap now takes the execution file as input and just executes it. So slap now injects some hash in this machine, and log slapper knows that hash, takes it, modifies it, and just injects into the indexer. And then you can see that search at showing that. So it's demo time. Okay, I hope you will be able to see that. Okay, so I started with showing the casual Splunk screen, which showing the Ozgun's machine's logs, because it's a valid machine and we compromised that machine. Once we compromised, we still have our own logs from this machine. There are a bunch of logs coming from our compromised machine, and this because we compromised this machine, probably blue team is right now working on to caught us, because these are already sent. So we need to find the time. We need to confuse some blue teams. So I'm showing that Splunk is currently working healthily on that machine. It's active. And then I just start the execution file, showing the execution file. This is the file we want the target machine execute. So second file is host file, which has the constants, variables we always want to change. So once you started the log slapper with sudo command, because you have already root privileges, and what it does is immediately inspects the real-time traffic and changes the host file's variables. Like in the host file, you saw that there's some IP and host name and their corresponding values to change. Once we started the log slapper, it immediately detects our IP and host name logs and just changes it. So right now, we should be able to see a log coming from Tirana demo, because we changed the Ozgun's machine's name into the Tirana demo. And right now, when I search Tirana demo, I'm seeing that some logs coming from a machine called Tirana demo. And actually, there's no computer with this host name in my demonstration, but I just made up. And now we have some logs. If some blue team member just trying to inspect that, he will be confused, because there's nothing a machine called Tirana demo, but it seems like they are. So while we are real-time inspecting the traffic, let's execute the slap now command, and it takes the argument as an execution file. And once I executed it, you can see that sudo blah blah command not found, because I'm just trying to execute some stupid commands, some stupid hashes. Like you can see that some SHA-512 hashes going around. I'm just executing them, creating some SIEM traffic, and in the meantime, log slapper just sees that log and modifies it. And there's some sleeps between them to mimic real person. And after the execution completed, both of the programs will shut down. Okay, so it's executed right now. So let's search for sudo command. So in Tirana demo machine, what can we see as the sudo commands? So let's start from the beginning. And now we can see that there's some comment going on, right? sudo ping ozgunsmaliciousite.com from the machine Tirana demo from the host IP 10.30.102, which is not existing, right? But there's log, there's evidence for blue team. Why blue team just being suspicious about that? So the target machine just send the ping to that machine, to the website ozgunsmaliciousite.com. After that, he executed sudo vget some randomware from that website. After installing the randomware, it just decompressed it and goes to that folder and executed it. So now it looks like a machine called Tirana demo 10.30.102 executed these commands in order, which is not true. This is the screen if you are able to see slap nav. You can see some hashes. And after the execution, we waited for like 30 seconds while obfuscated ransomware command is executed in background, some hashes. And SIEM log created by that command is immediately captured by log slapper and modified. And now it's reflected in Splunk Web UI. We can just combine these two programs into one program, but for demonstration purposes, I chose to split it into two programs. In Splunk Web UI, you can see that Tirana demo machine executed these commands in order. And this is the more detailed version. You can see that log is coming from Linux audit. Everything is proper. Host name is Tirana demo. Host IP is 10.30.102, and everything is normal. But you can also change, let's say, index name, and that will be more confusing, of course. So chapter 4, what can we do more about that? Endless ways to cause distraction. So any modification to logs, as you can see, have some severe consequences, including failing to detect an ongoing attack or just identifying a non-existent threat. In this section, we will just delve into the critical importance of the SIEM logs in detecting malicious activities. We can just blame others. We can just, in parallel, create a reversal alarm, create some critical events like we did. And with this way, we can just hide our noise. While they are dealing with some ransomware going on, we can just exfiltrate our own sensitive data. And we can also create our own scenarios, like Mimicat is just dumping NTDS DIT file from a domain controller, or someone just disabled the defender. We can do that. Or if that's not enough, we can just spam log, float the SIEM, hide the real data in crowd, and they will not be able to see. And if you are curious about the prompt, it's very dangerous black hat hacker, massive destruction in a room with full of servers, computers, cables are burning, hacker is breaking everything. Yeah, it lasts like 30 minutes to create that. So chapter 5, fighting back. So I need some blue team members. Maybe they are interested in that. So what are our hardening options? What are our hardening points? This section will provide guidance on how blue teams can prevent these attacks. And we also have some recommendations for SIEM creators, Splunk, or I don't know. I can't say that, I guess. Inspecting the weak points that made this possible, you can just create SSL TLS, right? You can just encrypt the traffic and it's done. But I hope it's that easy, but it's not. Because SSL TLS is just a direct solution comes to mind, but that's not easy because, most SIEM tools, including Splunk, uses plain text traffic between forwarders and indexers, and obviously which can be intercepted and modified by attackers, right? So while encryption, decryption, SSL/TLS mechanisms are available on the SIEM side, implementing them can just be an extra burden for the management. Because for both universal forwarders or just heavy forwarders, in addition to the added complexity of managing certificates and ensuring that your certificates is not expiring, it's worth noting that having SSL TLS in SIEM structure can also lead some delays because, in in a very large company, you have millions of logs in a second, in a minute. So some SSL TLS will lead to some delays on that side. And despite the drawback, you should do that, of course. But you should manage that carefully. Your certification can be expired, and this will be result in not capturing logs. But Splunk have hopefully some solution for that. I took that screenshot from Splunk site. They say that why is it important to secure your Splunk enterprise deployment with TLS certificates? Yeah, it's genius. It's important to secure your Splunk enterprise and forwarding tier infrastructure for the following reasons. So they are just explaining that you can increase the level of protection by obtaining and installing your own certificates. And they are just have some great recommendation to us about the default Splunk platform certificates. So Splunk platform installation package comes with a set of default certificates, and you can just apply them. But guess what? Problem is, because the root certificate is the same in every Splunk installer, anyone with the same root certificate can authenticate into and communicate with the instance. So Splunk has a solution in itself, but it's just using the same root certificate for all companies. So yeah, you should do your own certificates and manage them. And some operating system hardenings. In Linux, you can just, as you know, you can just kill the Splunk, kill the EDR, just kill around. You can apply some IP tables rules. You can create some NFQ to inspect each log. But in Windows, process injection things are a little bit harder, right? You cannot just inject something into EDR because they are using PPL, like PPL, protected process light. So that means you cannot just inspect the network traffic of the target service. But guess what? Yeah, Splunk didn't apply that. Splunk has no PPL, so anyone using Windows and Splunk can download just Echo Mirage tool, and using Echo Mirage plus system privileges, you can just inject into Splunk's process in Windows and can see whole traffic in plain text, and you can just modify that with Echo Mirage. So with Echo Mirage, you can just mimic our attack. So therefore, it's really imperative for SIEM creators to take actions against such an attack. This may include implementing additional precautions, adding some checksum mechanisms maybe, or modifying default settings and incorporating OS settings protections such as PPL. So chapter 6, this is the last chapter, and we will talk about our roadmap. As part of our commitment to continuously improve that research, we have a number of plans for future development and enhancements. These include our integration with some popular command and control frameworks, such as CobbleStrike. We are right now developing a module for CobbleStrike, so you can just use that SIEM attacks with CobbleStrike easily. And you can just make it a common step on this on your red teaming operations. Once you get the root privileges, you can just apply that attack and boom. Because blue teams still don't aware of that, so you can be quick. And we will improve the log slapper, of course. We can automate some well-known attacks, like let's say Mimikatz. We can just make that attack built-in. We will add some headers. Right now we are changing the hostname header, IP header, executed command header, but we can do more, and we will do more. We will make it more UI friendly, and of course, consistency. So thank you so much. That's me, and I can take your questions if you have.
So I came in a little bit late, and I'm not familiar with Splunk's infrastructure. On the earlier page, when you were talking about creating a man in the middle between the forwarder and the log aggregator, or whatever it was called, was that, you had like a Linux, yeah, that one. Mm-hmm. Is that saying the forwarder is just any particular testing? any particular box that is compromised, like just happens to be a Linux box in that system, in that context, or is the forwarder a specific Splunk infrastructural thing?
It can be all forwarders. Like it can be Linux, it can be Windows, it can be any machine on the target environment. It just needs to be Splunk installed, and if there's no Splunk on that machine, that's really a bigger problem for blue team actually. So you can, when targeting a company, if you just initially compromise a machine and gather root privileges, and if that machine has Splunk, just don't kill it because we are using it on our way.
Okay, and so then basically it can be anything can be compromised, and you just used IP tables just as a Linux example.
Yeah, IP tables is much more easier for that demonstration purpose, but you can, like I said before, you can use Echo Mirage in Windows to intercept the traffic, or you can just write some C# scripts to make some specific queue in Windows, but that's a little bit harder, I guess. So I just use the IP tables in my example to inspect all outgoing log packets, so I can modify them. You're welcome.
I'm wondering if you can obviously alter any kind of traffic that you have, like going to Splunk, you can erase logs as well. What would be the benefit of confusing the blue team? After all, you are gonna get their attention, and they're gonna look at that machine. That not always, usually doesn't serve a purpose. So why would you want to create more noise? Did you ever see that help in practice?
I'm actually not creating more noises. I'm obviously creating more noises, but I'm actually trying to distract them, because in any way, if you are using my tool or not using our research, you will create some noise, right? And you will get cuffed because you got just root privileges. But if you can have this ability in besides of getting root, you can just mislead them. Because once you get root privileges on a machine installed Splunk, you obviously caught their attention. Probably they are right now chasing you, and you need to distract them because you need some time to recon more, exfiltrate some sensitive data. That's why actually I'm creating another noise, or just I can spam tons of logs, and that will obviously draw their attention, of course, but they are already on their heels. They are already trying to catch me because I have root privileges and I have limited time. Thank you.
What do you recommend? You should use TLS on the server side or use inject instead?
Yeah, what do I recommend? I recommend to use SSL TLS in any way, despite the drawbacks of some delays and some other issues managing certificates. But I think that's the most solid way to harden that SIEM logs, because other option is using, some built-in modules developed on Splunk, and they may be not that consistent. So I think we should just create our own certificates and use it on SIEM. But be careful about the expiration dates, and managing them will be very hard. But this seems like the only way to mitigate that issue right now. Thank you.
Okay, Ozgun, thank you very much for your dynamic presentation today. Seems to caught people's attention, so any more questions, I'm sure Ozgun will be available in and around the common areas. It's now time for a lunch break. I think resume, actually, I don't know. I'll just check. Resume at 2 o'clock. Enjoy your lunch. Bon appetit.